Namaskar. My name is Sandeep Chaudhari, working as Assistant Professor in Department of Electrical Engineering, All India Shri Shivaji Memorial Society's Institute of Information Technology, AISSMS IOIT, Pune. This presentation is about synchronous motor. It covers the construction and working principle, the self-starting issue, why this motor is not self-starting, and methods to make the synchronous motor self-start. Constructional details. It consists of a stator, which is the cylindrical part. It is made up of silicon steel stampings. The stator core has slots on inner periphery to accommodate the three-phase winding. A three-phase winding may be star or delta connected. It is a symmetrical winding, 120-degree mechanically apart, which is accommodated in the stator slots, and a three-phase symmetrical supply is connected to this stator winding. The moment we connect three-phase supply, a rotating magnetic field is produced. So the rotating magnetic field can be represented like this, with NS poles rotating at a definite speed. So we have stator, which consists of stator core, stator winding, and which produces a rotating magnetic field. Next part is rotor. It is an electromagnet. The rotor is mounted on shaft. The rotor carries field winding, which needs DC supply, and DC supply is fed through brush and slip ring arrangement. The DC supply is connected to brushes, which rest on the rotating slip rings, and the connection from slip rings is given to the field winding. Please note the shaft, the slip rings, the field winding, and these rotor poles, they rotate, and brushes are stationary, resting on slip rings with some amount of pressure. The working principle is magnetic locking. As we know, we have got a stator which produces a rotating magnetic field, and rotor, which is an electromagnet. It is arranged like this. Just observe the polarity. The stator N pole, red one, and rotor S pole, green one. Unlike poles are facing each other on upper side. On lower side, the stator S pole and rotor N pole are facing each other. Unlike poles attract, so there is magnetic locking. And now the rotor has to follow the stator rotating magnetic field. So this is the working principle of synchronous motor. This motor, however, is not self-starting. This magnetic locking cannot take place on its own. This is because the stator rotating magnetic field rotates at ns, given by 120F by P, where F is the supply frequency and P is the number of poles for which the stator winding is wound. So it rotates fast, and the rotor has got some inertia. It cannot rapidly follow the stator, and that's the reason why the motor is not self-starting. Just see this animation. At a particular instant of time, let the stator N pole and rotor N pole face each other. Remember, this red field is stator rotating magnetic field, and green magnet is a rotor. Now this stator rotating magnetic field rotates in clockwise direction. At a particular instant of time, the stator N pole and rotor N pole face each other. So obviously there will be a force of repulsion, and the rotor will be repelled in anticlockwise direction. During this time, the stator rotating magnetic field continues to rotate, and in a fraction of a second, the polarity changes, and again rotor happens to attract toward the stator. Again, after some time, the like poles will face each other and repulsion will take place. So this repulsion, again attraction, repulsion, attraction, it takes place continuously. So the rotor is not continuously rotating, but it has got oscillations. So it just oscillates around itself and it cannot rotate through 360 degrees continuously. Thus the motor is not self-starting. This is shown in the diagram. At a particular instant of time, this is the polarity of stator magnetic field shown by red magnetic poles N on upper side, S on lower side, and rotor N pole on upper side, rotor S pole on lower side. If you observe the polarity, on upper side like poles are there, and on lower side also like poles are there. They are facing each other. So there will be a force of repulsion. Remember, stator rotating magnetic field, the red one is rotating in clockwise direction. So this is what happens. There is force of repulsion and the rotor magnet is repelled. It goes into anti-clockwise direction. Remember, the stator rotating magnetic field is rotating at ns in clockwise direction. Within fraction of second, the stator rotating magnetic field, it continues to rotate and changes its polarity as shown in figure 3. Now we have stator S pole on upper side and stator N pole on lower side. See the red polarities. The rotor, however, is in the previous position because of its inertia. And now, if you observe, unlike poles are present at the top and bottom. That is, stator S pole and rotor N pole are facing each other. And on lower side, the stator N pole and rotor S pole are facing each other. So obviously there will be force of attraction, and now the rotor tends to go towards this stator S pole and this part will go towards N pole. So it rotates in, tries to rotate in clockwise direction. In previous case it was in anti-clockwise direction, now it is in clockwise direction. And this will continue. Next situation. Figure number 4 is similar to figure number 2 because the stator rotating magnetic field is continuously rotating. So within fraction of second, again this polarity will be present. Stator N pole, red one on top, stator S pole on bottom side. The rotor magnet will be now again repelled because like poles are facing each other. So this continues. The alternate attraction, repulsion, and the rotor just oscillates around its mean position. And if the inertia of rotor is high, the oscillations will be very less and you will not observe the oscillation. It will be just stationary, look as if it is stationary. So we conclude that synchronous motor is not a self-starting motor. However, we have to make it self-start. And there are different methods to make it self-start. The first method is, it is started as a squirrel cage induction motor by using damper winding. The rotor construction is different for this motor. That will be elaborated in the next slides. Second method, using separate induction motor. This will be just driving the rotor near to synchronous speed. A separate induction motor will drive the rotor to near to synchronous speed, and then motor will be pulled into synchronism. In a similar way, third method, using separate DC motor, which is also called as pony motor. It will also drive the rotor near to synchronous speed. and pull the motor into synchronism. And last method, making it to work as a slip ring induction motor at start. The last method, however, is of theoretical interest. One by one, we will see these methods. First method is damper winding method. Now, if you observe, we have shown a 4-pole synchronous motor. Stator is shown cylindrical part and rotor, the projected poles, NS, NS. If you observe, round bars are arranged inside the rotor pole shoe. These bars are known as damper windings, and these damper winding ends are connected by means of end ring. This resembles to the construction of squirrel cage rotor. So if you observe, end ring is present at both sides of the rotor bars. So all the rotor bars are shorted at the end portion by means of end ring. As we know, the squirrel cage induction motor is a self-starting motor. So this motor will start as a squirrel cage induction motor. It will rotate. So it will be driven near to synchronous speed. At a particular instant of time, this N pole and this S pole will get locked. And this we call as the motor is pulled into synchronism. Now once this condition is achieved, which is known as magnetic locking, the motor can run at synchronous speed. So as if we are pulling it into synchronism. So this is first method. Using damper winding, you make it to run as a squirrel cage induction motor. Next method, using separate induction motor. If you see the figure, the synchronous motor connected to the supply, and to the same supply line we have got a 3-phase induction motor connected through a switch. This switch will either connect the motor, induction motor, to supply, or it will switch off the supply to induction motor. So at start, this induction motor is also made on along with synchronous motor, and this induction motor will drive the rotor of synchronous motor mechanically near to synchronous speed. And at a particular instant of time, the stator end pole and rotor end pole face each other. So the magnetic locking will take place. And once it happens, the induction motor will be disconnected from supply. So the purpose of induction motor is to just drive this rotor near to synchronous speed, let the magnetic locking take place, let the motor be pulled into synchronism, and then the motor will be disconnected from supply. So this is how the induction motor is used to start the synchronous motor. Using separate DC motor, which is also known as pony motor, same function. It is mechanically coupled to the rotor part of synchronous motor. DC motor, however, requires a DC supply, separate DC supply, and the DC motor will drive the rotor of synchronous motor. At a particular instant of time, the stator end pole and rotor S pole will face each other, so there will be magnetic locking. And now the motor is pulled into synchronism. Once it is pulled into synchronism, the DC supply to this motor, DC motor, will be cut down. And now the motor, synchronous motor, can run on its own. So in both cases, the induction motor and DC motor, they are just mechanically driving the rotor near to synchronous speed and allowing the motor to go into synchronism, to be pulled into synchronism. And then this mechanical external force is removed. Last method. This needs some modification in the field winding. The field winding is designed such that it can be converted into a 3-phase winding as well as it can be converted into a DC winding, simple DC winding. This changeover is possible by means of changeover switch. So at start, the field winding is modified to three-phase winding, similar to slip ring type induction motor. And a resistance is connected in the rotor circuit to limit the starting current. So this motor will be initially started as a slip ring type induction motor, three-phase slip ring induction motor. It will be pulled into synchronism, and then the changeover switch will be again operated, and the winding will be converted to simple DC winding, and DC supply will be fed in to the field winding. So now it will be a normal synchronous motor which is pulled into synchronism and running at synchronous speed. So this is what we have studied: the construction and working principle, the self-starting issue, why the motor is not self-starting, and the methods to make the synchronous motor self-start. For more information, you can log into our institute website www.aissmsiyt.org. Thank you.